Good morning, everybody. Welcome back to Math 105. Plan for today is we're going to start Standard 4, start talking about logical implications, which is kind of the last major type of statement we're going to be looking at. After this, we're going to stop looking at what are the different, this is going to be our last standard of, here are the different types of mathematical statements we'll see throughout this course, and we'll start moving on to how can we use these standards in interesting ways. Got my usual office hours at 10 o'clock today, and 10 o'clock this morning, 2 o'clock this afternoon. Tomorrow I'll have an office hour at 10 in the morning and 1:30 in the afternoon. As a reminder, quiz 3 is due tonight by 11:59 p.m. Yeah, so I've graded all the quizzes that I'd received up till about 4 o'clock yesterday. And I've not yet updated Blackboard with everybody's kind of total standard scores, but I have those. And if you go in, since Monday, turns out I found out that the thing I did Monday morning didn't let you see feedback on individual questions, but I'm pretty sure I figured out how to do that. It's on a completely different page than the rest of the quiz settings. So of course I didn't see it at first. But you should be able to now see feedback for each individual question. There's a new tab up on the Blackboard page for grades. If you go to that tab and click on it, you should see, it should give you a list of all your assignments so far. And if you click on the ones for the individual quizzes, you can then click on your score, and it should show you your, did you get a mastery or not, what was your letter grade, and you can go through each individual question and see my feedback on it. Any questions or comments before we get started? Okay, so Standard 4 is going to be a standard that I expect will take us a couple classes, a little bit more of it, like Standard 3 did. And Standard 4 is all going to be about implications, which are, mathematically speaking, just going to be if-then statements. So, implication is a compound statement. Compound statement here. Nobody stopped to remind me to do the joke of the day. Why is it not a good idea to teach horses analytic geometry? Because you shouldn't put Descartes before the horse. Anyways, an implication is a compound statement. Compound statement meaning it's formed by taking two smaller statements and smushing them together. It's a compound statement of the form if P, then Q for statements P and Q. So in Standard 3, we had talked about two ways that you could take two statements and combine them into a single compound statement by throwing an and between them or by putting an or in between them. This is another way that you could take two different statements, P and Q, and sort of combine them into a single statement by saying if P, then Q. And what this means is under all circumstances when statement P is true, statement Q has to hold true. So if we were to look at a Venn diagram for what it means to say if P, then Q, what that really means is that if we were to form kind of a circle for Q in our Venn diagram and a circle for P, put the Q in there. The circle for P has to lie entirely inside the circle for Q, which basically, mathematically, just means that if you are in a situation where statement P holds true, and we have the implication if P, then Q, the only way for a statement P to hold true is if the statement Q is also going to hold true. And if you look at this Venn diagram, if P then Q is a true implication, is it possible for statement Q to be true without statement P being true?
P without Q, no.
P without Q, no, but how about Q without P?
Yes.
Yeah. It is possible for Q without P to be true, but it is impossible for P to be true without Q being true. So let's look at a quick example where we take a look at this, where we take a look at a implication. And assuming the implication is true, with ice cream and tennis, two of the greatest things, what are the different possible scenarios that can occur under that implication? So suppose that you're gonna go play a tennis match, and before your tennis match with your friend tells you, I tell you what, if you win, then we will go get ice cream. So we're going to assume that your friend gives you this implication. If you win the tennis match, then we will go out and get ice cream together. I want you to take a minute and take a look at the four situations at the bottom of the first page. And I want you to think about what are the different, out of these four scenarios, which ones are possible to occur, assuming the implication is true. So go ahead and take just a minute and see if you can think about which of these four situations are possible, assuming your friend is telling the truth when they give you this implication. So here's our implication. If you win, then we will go get ice cream. So this is going to be an implication that's of the form if P, then Q. What would our statement P be in this implication? You win. Correct. Good job. You win this round. So this is going to be our statement P. It's just you win. It's not including the if. The if is sort of like the connectives and or, in that it's not part of the individual statements. It's just a word that's used to make the compound statement. And what would our statement Q be? The thing that we say has to happen if statement P happens.
We will go get ice cream.
We will go get ice cream. Indeed. So our P here is if you win. Our Q is we will go get ice cream. And so this is the implication that we're making. If P, then Q. If you win, then we will go get ice cream. So, what about, is scenario one possible? In scenario one, we say you win, and you go get ice cream. I would say so. Yeah, this one is totally valid. A possible scenario. Which ones of P and Q are occurring here?
Both of them.
Yeah. If we wanted to write this statement symbolically, using kind of the symbols for P and Q, how could we do that?
P, like the horseshoe, Q?
This one or this one?
I don't know if this one.
Why don't you say it first? P and Q or P or Q?
Oh, I'm sorry, I misunderstood the question. P and Q.
P and Q. Yeah. So if we're making the implication if P then Q, P and Q is going to be a totally possible outcome from that. If P and Q occurs, then the implication if P then Q will be true. How about statement number 2? You win the tennis match and you don't get ice cream. What's the point? See some head shaking? Why do you say no?
Because in that statement, P is true and Q is not, and we can't have that with an implication.
Yeah, exactly. Our implication says P being true must necessitate Q also being true. So here we have a situation where statement P is true and statement Q is false. And we're just going to say that that in this scenario, P and not Q would make the implication if P, then Q, a false one. So, if you win, then we will go get ice cream would be true if you win and you get ice cream, but it would be false if you win and you don't get ice cream. Oh, by the way, I forgot to mention this. If we looked at our Venn diagram, situation 1 would occur somewhere inside of the bubble for P. Where we're in the circle for P, meaning P is going to be true. We're also inside of the circle for Q, so statement Q is also going to be true. And that kind of matches up with the Venn diagram for simplification. Whereas if you look at the Venn diagram for statement 2 here, you win and you don't get ice cream. Basically, you're saying you need to be inside of the circle for Q you need to be in the circle for P without being in the circle for Q, and that's impossible in this Venn diagram. There is no place where you can put a number 2 that would make it inside the circle for P without also being inside the circle for Q. How about the third one? You don't win, but you do get ice cream. Meaning we have not P and Q.
It is a possible scenario,
It is a possible scenario?
because it would mean P is false, but with Q being true, you can be inside the Q circle without being inside the P.
Yeah, it's totally possible. While it's impossible to be in the P circle without also being in the Q circle,
Yeah.
it is totally possible in this Venn diagram to be inside of the Q circle without also being inside of the P circle. And so, if you don't win, but you go get ice cream anyways because everybody had fun, say, that would actually make the implication true. And finally, how about this last scenario? You don't win, you don't get ice cream, just a terrible day all around. Is that a possibility? If you don't win and don't get ice cream, would that be a scenario under which if you win, then we will go get ice cream would be a true statement? I agree. Because that would be a scenario where Q is false and P is false, which you could totally get from this Venn diagram, just from being, say, out here. So, not P and not Q is going to be a situation that would make if P, then Q a true statement. It's kind of interesting to me when you think about implications in this way, because if you think about it, if we're making the implication if P, then Q, and statement P ends up being false, then your implication is true no matter what. If P is false and Q is true, the implication is true. If P is false and Q is also false, the implication is still going to be true. It's true under every circumstance under which P is false, but if P is Q, it also has to be the case that Q is true in order to make the implication, if P, then Q, a true statement. So really, the implication is just ruling out this scenario where P is true and Q is false. Any kind of questions or comments about how this implication works? Okay, I would like for you to turn to the second page. I gave you 4 mathematical implications, and I would like for you to determine if each of them is, for each of them, whether it's true or false. Keeping in mind that the implication is always going to be true unless it is possible for this first statement to be true and yet the second statement to be false. Take a minute and as always, if you both feel comfortable, you're certainly welcome to discuss things with your neighbors. What do you all think about this first one? If 2 lines are parallel, then the 2 lines must then the 2 lines do not intersect. Wayne, I see you nodding at that one.
That's true.
Why do you say true?
These parallel lines never touch, so they'll never intersect.
Yeah, that's actually going to be the definition we use later on for what it means for 2 lines to be parallel, is that they don't intersect. And under this circumstance, I would say every circumstance under which P is true is also going to be one under which Q is true. So I think I would agree with Blaine here. This is going to be true. So because if this is our Q, and if this is our P, this implication is going to be true since every time P is true, Q must also be true. How about the next one? If your computer stops working, then your computer has a virus.
It's not true because, or not always true rather, because it's possible for the first statement to be true without the second statement being true. For example, your computer could stop working because, somebody cut the cord or something.
Somebody cut the cord. Maybe your computer stopped working because you hit it with a sledgehammer. There's lots of ways for your computer to stop working. It's certainly possible for your computer to stop working because of a virus. But unlike in the first example, it is totally possible for the statement P here to be true without statement Q also being true. And so I agree, that would make this implication false. I mean false because it's possible for P to be true without Q being true. And since that's a possible scenario, that we have P true and Q false, we have to then say that the implication is a false one. Even though it is possible for both P and Q to be true at the same time, the fact that P being true doesn't necessitate Q being true means that the implication has to be considered a false one. How about this one? If x is greater than 10, then x is greater than 7. Thumbs up? Why is that? Yeah. Under every circumstance of which we have a number that is greater than 10, that number must then be greater than 7. So here's our P, is just x is greater than 10. Our Q is going to be x is greater than 7. And we can say this is going to be true because if P is true, Q must be true. It's impossible to have a situation where P is true and Q is false. Finally, how about this one? If x is greater than 7, then x is greater than 10. It's going to be something that we'll later call the converse to the previous statement.
The first one can be true, but it can still be a number that's less than 10, like 8 or 9.
Yeah, x could be 8 or 9, or 9.14159. Pi plus 6. These would all be circumstances under which we have an x for which the first statement is true. 8, 9, pi plus 6 would all be numbers that are greater than 7, making the first statement true. But they would also make the second statement false because those are not numbers that are greater than 10. So the implication here is going to be false, since again, it's possible for P to be true and Q false if, for instance, x is 8. That would be a circumstance under which P is true, Q is false. Therefore, since such a circumstance exists, the implication is going to be false. Unlike the previous statement where it's impossible to find an x that is greater than 10, but not also greater than 7. Any questions or comments about any of these? So basically, whenever you're given these sort of implications and you're trying to determine are they true or false, you just have to think, are there any scenarios out there under which P can be true and Q can be false? If you can find a scenario that would make P true and Q false, then the implication is false. But if you can't find a scenario where P is true and Q is false, then the implication has to be true. Okay, awesome possum. Let's move on to symbolic notation. So the symbolic way to write if P then Q is to just write P and then an arrow pointing to the right towards Q. So if P, then Q, can be written P, arrow pointing to the right, Q. That's going to be kind of our symbolic notation. And so I have another challenge for you, which is, given the three statements on this page, or well, I give you a P, Q, R, and S, I would like for you all to find out how can we write down in words the three compound statements towards the bottom of the page. And this is going to kind of test what you remember from Standard 3 as well as from the first part of Standard 4, because there's also some of these other connectives in here as well as some negation. The same sort of exercise we've done a couple times before back in Standard 3. I think it's good to kind of try and do the same thing sometimes when we have to build in these new sorts of symbols, like the right pointing arrow. What did you all think about this first statement? P, arrow to the right, S.
If Jill is not at home, then Jill is not studying.
Yeah. You can write this as if P, then S, which means the same thing as saying if Jill is not at home, then statement S, Jill is not studying. How about this next one? Not P, right arrow, Q and R.
If Jill is at home, then Jill is asleep and sick.
Okay. So you negated Jill is not home by saying Jill is home, not Jill is not at home.
I mean, it could be either one.
It could totally be either one. They're logically equivalent. Yeah, that's how I negated it, is just by saying Jill is home. So if Jill is home, then what was the second half of your statement?
Then Jill is asleep and sick.
Then Jill is asleep and sick. I see you kind of combined Q and R so that you didn't have to use the same. You didn't use the same subject twice.
Is that okay?
That's totally okay. It's something I think we sort of talked about in Standard 3. If you have two statements that you're combining with an and or an or that have the same subject, in this case, Jill is asleep, Jill is sick, then it's fine to do it either way. Say Jill is asleep and sick, or say Jill is asleep and Jill is sick. Yeah, that's totally fine. So if Jill is home, then Jill is asleep and sick. Oh, if I were Jill, I would not want to go home in that situation. Well, asleep is cool, but sick is not. And finally, how about this third one?
I put down, if Jill is not studying or Jill is not sick, then Jill is not asleep.
Jill is not studying or Jill is not sick, then what was your
Then
conclusion?
Jill is not asleep.
Then Jill is not asleep. Actually, so here we're saying Jill is not asleep if either Jill is not studying or Jill is not sick. So in other words, the only way for Jill to be able to sleep is if Jill is both studying and being sick. I take back what I said about that second one. This is the worst situation for Jill. Because it's kind of requiring that Jill is both studying and sick in order to be able to sleep. Yes.
It's both, she has to be both studying and sick, or is it an or statement? She either has to be studying or sick.
Oh, we haven't talked about how to negate this yet.
Okay.
But that will be what it means, is that we're basically, since we're saying if Jill is not studying or Jill is not sick, if at least one of these two things is happening, not studying or not
Oh,
sick,
okay, then she's not asleep.
then it will have to be the case that not asleep. So if she is asleep, neither of these two things can be happening. She has to be both studying and sick.
So, what would the difference be between saying not studying and not sick, as opposed to not studying or not sick, since both have to be not the case for her to not be sleeping?
Here not studying or not sick means if either one of these, if just one of these, or if both of these events occur, not studying, not sick, then it has to be the case that she can't sleep. She's not asleep. If you replace this or with an and, then we're saying both of these events have to occur, not sick and not studying, in order to require the event of Jill not being asleep.
Oh, okay, so one of them can be true and.
If one is true and the other is false, and we have an or statement, Jill cannot sleep. If we replace this or with an and, then let's say if Jill's not studying but she is sick, if we replace this with an and, then both of these would have to be true in order to require Jill not being asleep. These are a bit of harder statements to sort of interpret logically, like what are all the different ways that we can, especially because I put a triple negative in this statement. I think that's making it a lot harder to interpret. Questions about any of these? Same sort of way in which you would symbolically interpret back in standard 3, when we had the squiggles were negations, the little V symbols were meant or, and the upside down V's meant and. But this time, we have this extra quirk of having arrows pointing to the right that just mean if first part of this thing, then second part of this thing. Okay, moving on. This next page is a little bit sinister. Now we're going to assume we have 3 statements, P, Q, and R, and we don't know what they are. But we do know that P and Q are true statements. We also know that R is a false statement. But that's all we know about P, Q, and R. And our goal is to see if we can determine if a bunch of these kind of compound implications are going to come out to be true or if they're going to come out to be false. So let's try the first one together. If P is true, Q is true, and R is false, must it be true that if P, then Q and R? This one's a bit trickier, and I think it helps to kind of write down and piece together which of these are true, which of these are false to start.
Do you want us to answer it, or are we gonna write it down? Like, do you want
You're
me
welcome to answer it, and then I'll write down what
I
you
think
think.
it's false because since R is false, then there can't be a situation where the implication is true. So you can't have, if P is true, then those two things, for the statement to be true, the conclusion has to be true. The second part of the statement has to be true as well.
Yeah, I would agree. So here's kind of how you can interpret this. I think you're showing. I'm just going to take what you said and rephrase it slightly. P we know to be a true statement. That's something we were given, is that P is a true statement. We also know that Q is a true statement, and that R is a false statement. So we can really interpret this question as asking, if we have three statements, must a true statement, if a true statement, then a statement that is both true, a true statement and a false statement. And so you might think about it in this way. P is always going to be a true statement. If statement Q is true and statement R is false, what can we say about the statement Q and R? Is Q and R going to be a true statement or a false statement? It's going to be a false statement because of this and symbol. In order for Q and R to be true, it has to be the case that that Q is true as well as R is true. That's something we saw back in Standard 3. And so here we're given a scenario where we have true statement and false statement that has to come out to false. And so the question ends up becoming, if our implication is if true statement, then false statement, does that implication come out to be true or false? It's going to be false, because we said that's the one time an implication is going to be false, is if we're saying if true statement, then false statement. So I totally agree. I think if P, then Q and R is going to evaluate the false, because we're really asking in the end, if something true, then something false. No, that makes the implication false. I'd like for you all to work through the next couple on your own. R or not P implies Q. Q implies R, and not P implies not Q. See if you can go through and make sense of each of these, and see if you can find out whether these statements, these compound statements, evaluate to true or to false. I think this one's a little bit more challenging, and I think if you're not sure where to get started on this one, I think it's helpful to kind of write down each of the individual pieces, which ones are true, which ones are false. So in this case, this one's true, this one's false. I recommend starting by doing the same thing.
Say it's true.
Oh, well, we'll come back to it as a class in a minute and talk about it.
Okay.
Spoiler.
Did you make it say that's true? Why?
Q is true.
Encourage you to talk to your neighbors or to flag me down. I think you have ideas.
Yes, that's really, it's obvious. First, we have a false implication. It's the first one, so that's not that thing. We have to also have false implications. So if it's true, Q is true, yes. So maybe Q is false, so it's false.
Looks like everybody's quieting down. So would anyone like to share their thoughts on this this one right here? R or not P if R or not P, then Q. So I'll look like you had some ideas on this one as I walked around the room.
We got back on the first page when we said you can lose a tennis match but still go get ice cream. Q can be true without the first thing being true, so it's true.
Yeah, so our conclusion is true. Oh, so you're saying since the conclusion of the implication is true, it doesn't matter what the first part is, the whole thing has to be true? You're absolutely right. Let's go through each piece individually though, just so everybody's on the same page. So here, what we're really saying is R, which is a false statement, or not P. Let's see, P is true, so the negation of P would also be false. The question we're really asking is, false, if false or false, then true. Is that a true or false implication? Well, let's combine these. If our first statement is false, and our second statement, if R is false, and if not P is false, is R or not P going to evaluate to true or false? If we take, yeah. Since both of these are false, R not and negation of P individually are both false, that will make our or statement false. This is the same as saying we have something false. If something false, then something true. Turns out to be true. Because our implication, our if-then statement, is always going to be true unless the first piece is true and the second piece is false. Here we have a false, if false then true situation. If we were thinking back to our ice cream scenario, our implication was if you win, then you get ice cream. We said if you don't win, but you do get ice cream, the implication still holds true. That was our situation number 3 here. Here, it's the exact same thing. If something false, then something true, will always be a true implication. Just because it's not that dreaded situation number 2, which we had here, where our first bit was true and our second bit was false. Any questions or comments about this one? Oh boy, how about the second one? If Q, then R, and if not P, then not Q. This one's a bit more complicated.
So essentially, the condition, I don't know how to describe this in an uncomplicated way. Conditional.
I think it's gonna be complicated no matter what.
Okay, conditional on the left side is true to false, which means that it's false overall. And then the conditional on the right side is false to false, so it's true overall. And then the statement as a whole isn't an implication, it's an and statement. So its overall value is false because in an and statement, they both have to be true.
Nice job, I agree. Yeah, here I think we have to look at our two implications individually first. Our first implication is Q, if Q then R, which is saying if something true, then something false. And this was our situation number 2 that made the implication a false one. Over here, not P, if not P, then not Q. Since P and Q are both true, not P and not Q are going to be false. And if something false, then something false actually evaluates to true. Because that was our situation number 4 over here, where you don't win and you don't get ice cream. Still makes it a true statement that if you were to win, then you would get ice cream. So we end up with something false over here on the left, our first implication. Something true over on the right, our second implication. And then it's actually going to be the case that if we have 2 statements, the first of which is false, the second of which is true, is the and statement going to be a true one? No, it's not, because it's an and statement. The and statement can only be true if both of the 2 individual pieces are true, which is not the case here. So this very complicated double implication, lots of negation, what a situation, is going to end up being a false one. I think this was a difficult activity, definitely the hardest thing we've done today. This is why I think it's very helpful to me personally to kind of write out which of these individual pieces are true, which of these individual pieces are false, and then to kind of go slowly and methodically through and say, all right, true implies, or if true then false, that comes out to false. If false then false, that comes out to true. And just kind of go through very slowly at each step saying, what does each individual piece come out to in order to make a claim about what does the entire statement tell you. Any questions or comments about any of this implication? Okay, now let's go a couple minutes. When we come back on Friday, we're gonna continue working our way through this packet. And on Friday, we're going to talk about how do you negate an implication, and as well as if you have the implication if P then Q, what's the relationship with that implication and the implication if Q then P? Turns out they have a special relationship with each other. Have a good one. I'll see you all on Friday.
Thank you. I love this.